Hey, so thank you all for joining us. So how many of you feel like are you familiar with IDEO? Like, raise your hands. Pretty familiar. Okay, great. How familiar are you with blockchains? Hands up. Okay. So if you said like no to both of those, we're gonna do like really quick intro, so don't worry about it. Thank you for coming. We're gonna talk about human-centered design. We are a human-centered design firm, and that means that we tend to look at things through three different lenses. So we look at them through kind of the human lens of desirability, we look at them through the technical lens of feasibility, and we look through the business lens of viability. And so as a human-centered design firm, we start with the human element of desirability, except in the CoLab, where we start with the technology first. So we focus on emerging technology and understanding how it can fit into people's lives and solve problems for them and meet their needs, their desires. So we do this in collaboration with a whole host of partners. And they're not even all on this slide. We work with about 15 corporate partners who come and actually sit with us and participate in prototyping sprints 4 times a year, where we're collaboratively building prototypes to better understand blockchains and other emerging technologies. We also work with various academic institutions and recruit fellows from those institutions. And we have a lot of partners in the startup space who are doing cool things with blockchain technology. So let's talk about blockchains. What are blockchains? Well, blockchains are the technology behind Bitcoin, which was the first peer-to-peer decentralized digital currency. Now, what makes Bitcoin different? It's that it allowed, for the first time, value to be moved rather than just copied in a digital form. So think about how things work in a digital world, right? If I send you a photograph or a song or a PDF, I still have a perfect copy of the original. I can make 1 million copies, send them to 1 million people, and I still have the original. And that's great. That's done amazing things, right? It's enabled all sorts of new kind of media and forms of expression and communication, but it's not great for money, right? If I can copy a $20 bill and send it out 1 million times, and I still have my $20 bill, pretty soon money is going to be worthless. So the ability to digitally transfer something rather than just copying it is a really big breakthrough. So Bitcoin does this through the use of a blockchain or a distributed ledger. And there's a kind of fancy description here. The really simple one that I want you to focus on if you're like, I don't really know what a blockchain is, it's a database that we all agree on that is, it is append only. You can add things, but you can't go back and change things. So it's immutable in that sense. And it's got line by line permissioning. So you can only change entries that you have permission to. Right? So I can't update your account, I can only update my account. So given that this is a little bit different from what we've seen in the world before, how do we think about designing for blockchains, assuming that they will become relatively ubiquitous? And when I'm talking about design, I'm not just talking about user interfaces, I'm really talking about trust and how we guide users to understand how things are different when they're interacting with blockchains than when they're interacting with other services that they're already very used to, right? There's a lot of expectations that we've built up over decades of interaction in digital context where paradigms that we're used to may no longer be true when you bring a blockchain into the mix. So one of those is the idea of kind of permanence and irreversibility. So little Calvin and Hobbes comic, right? If you have bread and you make toast, you can't go back to bread. You now just have toast, right? So that's immutable. You can't like reverse this. There is no control Z when it comes to blockchains, right? So if you're used to like using kind of the undo send feature in Gmail, stuff like that, like you can't undo stuff. So you have to be really careful and make sure that you are doing what you mean to be doing. So let's say I want to send my friend Jesse some Bitcoin, for Jesse's birthday. And I'm like, okay, here's, a very generous birthday present. And I hit send, and then I get a message back. It's like, hey, Chris, I didn't get anything, but here's my address. So I sent to some random person's address because there's actually a difference here, right? So you have to be very careful and make sure that you're actually sending where you thought that you were going to be sending. You're missing the amount, right? If I meant to put like 0.001 Bitcoin and I send 0.1 Bitcoin, it's up to the person I send it to give it back. I can't call the credit card company and be like, hey, that was an accident or something. Can you send it back? It doesn't work that way with a blockchain. What's a context, though, where it's really desirable, right, to have this permanence, this irreversibility? This is a prototype that was built in the CoLab by some fellows, actually, I think in about 3 days. We call it the Glock chain. And the idea, the idea here is these were guns for law enforcement officers. And the idea here is that every time it is unholstered or the trigger is pulled, it registers that on the Ethereum blockchain publicly. So it puts a record of the gun being drawn or a shot being fired on an immutable public database. Now, law enforcement officers are already required to report when either of those actions happen. So this can actually automate the process and also create more trust that the reports that are coming out, like nothing is being hidden, it's not being changed. The core kind of details around that event are getting logged. So this we thought was a nice provocation in terms of places where immutability and permanence can be really seen as valuable. So to sum it up, permanence or reversibility, it's scary, but it enables us to do new things. So continuing on that is the idea of key management. And I'm not talking about house keys, I'm talking about cryptographic keys. So usually you're talking about like 30 some odd strings of like random characters that you use to generate digital signatures. They're kind of like passwords in that you want to keep them private, but you can't like reset them, and there's no one who can help you with that. So the first rule is don't lose your keys, and the second rule is don't let anybody else get your keys, because if they do, they have all the assets that are associated with those keys. So again, here's the example, right? We're used to the idea of password recovery. You forget your password, you can recover it. The service can help you with that, reset it. That is not true when you're dealing with private keys. So how do you manage this? There's a number of different approaches that can help users in different ways. So the first is we can go back to a bank-like service like Coinbase that can actually manage your keys for you. That's one option, but it's kind of going back to old paradigms rather than pushing some new ones. The next is MetaMask. This is a browser extension that actually kind of manages the keys, helps you use them in the browser in context, but that keeps them locally on your machine. Then you can go to, there's a ledger wallet, so it's a dedicated hardware device, right? So it's air-gapped, it's not connected to the internet directly. You'd have to like connect it by wire. It's got a secure place to sign transactions with the keys. So that's one way. So it's again going back to kind of calling back as designers, thinking what are people used to? We're used to keeping these physical things safe. So that's when we can do it. Or if we want to go really old school, you can actually just write down a passphrase or the key itself and just put it on a piece of paper, stick it in a vault somewhere so that it's safe. We've had, as humans, we've had like tens of thousands of years of practice of keeping physical things secure, and we've had just decades to learn how to try to keep digital things secure, and we're really not good at that yet. So if you really want to keep your keys secure for high-value stuff in a blockchain-based world, you're probably reverting to a physical form factor in some context. But for some that we want to use more actively, you're going to need to expose it to a computer on a fairly regular basis. So don't lose them, but they're going to allow us to have new kinds of privacy and convenience. One of the ways that manifests itself is when we talk about identity. So you go to a website and for the first time, you've got to put in your email address, create a password. Hopefully it's not the same password used on every other website, but it probably is. The nice thing is keys can act as a form of identity authentication across different services. So it means you can bring your identity with you, right? You don't have to create a new identity on every service. You can actually So it makes your identity kind of interoperable across these different services. This is one example. Augur is a decentralized application. It's a prediction market, so you can place wagers on the outcome of various events, finance, sports, politics, the weather, whatever you want. But it's a decentralized protocol. There is not a company with servers that you can just have them like log you in. You need to bring your own keys, bring your own identity to this context using various services that they support. So this seems kind of like Facebook Connect, right? It's like you can just go there and use the same identity across. What's different is you actually control the keys. You own your identity, as opposed to Facebook, which Facebook owns your identity. If they decide to shut down your account, you're out of luck. And then you're kind of locked out of services, or you're gonna have a really difficult time using all these different services that you've been using Facebook Connect to help you log into. You also have to worry about Facebook collecting data on you and knowing every time you're interacting with any of these services where you're using Facebook to log in. Here, if you use keys that you control, then you're the only one who needs to know that you're interacting with these services. So if we're using keys for identity purposes, what does that mean for privacy and transparency? Because remember, we've talked about the fact that blockchains are these public shared ledgers. You can verify information, and it's immutable. But do you really want a lot of information about your identity, about your activities, going in a public place, right? Probably there's some things you're okay with, but a lot of things you're not. So on the positive side, right, you can prove what you have and where it went. So think about one example, Bernie Madoff, right? We did not collectively, right? People who were investing in Bernie Madoff did not do a good job making sure that he actually had the assets that he said that he had. With blockchain-based assets, the person who, when they say like, oh, I've got so many assets, you say, prove it. And they can actually prove they do control the assets they say they control. They can prove they took the actions. You can verify that. And you don't even have to trust them. You can verify for yourself that they do have the assets that they said they had. Think about a nonprofit, right? That they can, if they're using blockchain-based payments, you can actually show that, okay, I can see where the money was going, how it was spent. And you can actually verify that it was being used for the purpose it was supposedly being used for. Then there's the flip side of transparency, which is privacy, right? If you are a business, if you're an investment manager, you don't want all of those activities being public to everyone, right? If you're a nonprofit, you maybe don't want the individual salaries of your employees to be public information. So we want to have some degree of privacy while also having that verifiability. So there are a number of things that we can do to help fix that situation. One of these is something called a zero knowledge proof. And it's being used in one place, most notably by a currency called Zcash. So there's like really fancy math, but basically what zero knowledge proofs enable is I can prove to you that I know some piece of information without revealing that information to you. I can prove the information that is contained here is, that it says my birth date is such that I'm over 21 without revealing the exact birth date, right? We can do proofs like that where you're sharing the relevant information, but maybe not all the details, and only revealing the details to people for whom they actually have a reason to see the exact information. So these are all collectively some really kind of different design challenges than we may interact with in other settings. So as designers, it's our responsibility to think about the people that are using these applications, that are interacting with blockchains in various ways, and help them understand these new paradigms. So I'm going to walk through a really quick example that we actually Shuya discovered while we were putting together this presentation. So here is an example. Protecting someone, there's like this Bitcoin wiki page, and it's got an example of a private key. And you can see up there's the private key. But if you copy and paste it, it doesn't paste the same private key. It actually appends, sample private key, do not import. That's because there were a lot of people who were going to this wiki and they were seeing, oh, here's a private key. Oh, I'm going to trust me. I'll just use this as my private key. Problem is, it's a public private key. So as soon as they sent any money there, immediately somebody else was like taking their money. So people were losing money. good design thinking got a solution in place that would have an extra barrier, extra layer of friction, and realize, oh, maybe I shouldn't be doing that. So yeah, here's what's going on in the back end, right? It's kind of change the HTML, what was happening here. So pretty simple, pretty effective. That's the kind of thinking that we need in this space. Because of that kind of irreversible paradigm, you don't want people to make a mistake that they can't undo, can't get back. So it's kind of a host of questions that I would pose that are really important to think about along with these themes, right? How can we help people know, how might we help them know that they're going to take an action that's irreversible, as in the case of the keys? How might we learn and follow best practices for keeping keys safe? Understand how identity is working differently with blockchains, and really think about it in the context of transparency and privacy. When can we verify information? When should we teach people to do that verification? And how can we help them preserve their privacy, or at least be aware when they're maybe making information public that they didn't want to? So that's the talk today. Now we're gonna kind of open it up for you guys to ask questions, and we'll also take some questions, I think, from Twitter as well. So, yeah. No questions.
I have a question
thoughts?
from YouTube.
Question from YouTube.
Question from AJ. Is there any way to validate a transaction before sending it?
Is there any way to validate a transaction before sending it or committing it? It depends what you mean by validate. The nice thing for Bitcoin addresses is like there's a checksum, so you're not gonna have just like an off by one character situation. But in terms of validating that it's going to the right person, really just check with them, make sure that there's not like you're not being man in the middle attack, or somebody else is like pretending to be them and substituting in their own address. So yeah, if it just is it the right address, just make sure you double, triple check with the person. Make sure you've really got the right one before you send it. Yeah.
So a lot of design thinking has iterations involved in it.
Yeah.
And this seems something that you might not be able to just release to the public, get feedback right away. So how does design thinking kind of change?
Great question. So for those who couldn't hear, the question was, in design thinking, we often like kind of move fast, we iterate, we do prototypes, we break them, we try again. And how does that work in this paradigm where if you can't fix things oftentimes? That's a great question. I think that's one of the reasons why any like public blockchain also has one, or in most cases, multiple test nets to actually go into a live test environment and try things out. For example, I use the Augur as a prediction market. They've got essentially a bounty program going on right now where they're saying, hey, here's the contracts as we plan to release them. Once we actually release them, we're not gonna be able to change them. So we're gonna offer up like bounties to have people try it out. And if hopefully people claim the bounties, break it, and they'll iterate and try it again. So there are ways to get at that. I think a really important thing is you don't have to necessarily, again, deploy it live and make this the final thing. You can get in front of users, you can test with them in some lower stake settings. Yeah.
I have two questions. How do you design around the fact that so blockchain block times are not the same that we're used to in normal web apps, right? So the user has to wait for, like I said, 15 seconds or so on Ethereum, and design around that question. And another one is, in a web app, you have all the transactions, and in the blockchain environment, you have to basically sign every single one of them, which is not really ideal. So we want some sort of a small transaction base, and not necessarily monetary.
Someone lead against the light switch, I think. There we're almost wrong ones. There we go. Okay, great. Okay.
So 15 seconds and all right, sorry.
Okay.
You got
So the 15, yeah, so the delays and the frequent need to okay, so the first question was around like, how do you deal with the fact that like 10-minute block times on average for Bitcoin, 15 seconds for Ethereum, there's these delays in terms of actions. That's tricky. It needs to be very clearly communicated to the user what the state is. Actually, a friend and collaborator at the CoLab, Matt Condon and Michael, I'm forgetting his last name at the moment. They got a company called XLNT, Excellent. They're developing a framework called Gnarly, which is it's basically helping to think about the UI in dealing with what they call the severe asynchronicity for dApps. And so they've got this idea of kind of like optimistically showing the user what's going to happen, but also make very clear that this is not finalized yet, right? So you say, optimistically, this is where it is, but very clearly communicate, like, don't 100% count it yet. And just kind of stay in contact with the user and show them as the state is updating. It's a tough challenge, and I think it's one that no one's got a good solution for. I think they're making a lot of moves in the right direction. But as kind of an industry, right, everyone's going to be trying out different things, seeing what's working, and hopefully sharing best practices. The second question was around dealing with the fact that you need to sign every transaction. What I would say is generally push for applications where you're only signing and only putting stuff on the blockchain, the minimal number of things that need to go on chain. There's cost reasons to that in addition to user experience. There are ways with different types of applications and contracts where you can essentially delegate the ability to sign up certain types of transactions. So there are ways to get at it. Ultimately, we're going to need to think about delegating keys to different contracts and services to sign only in certain contexts. And know when are the ones where it needs to actually get pushed back to the actual human who is using it and say, like, this is an important one. You need to make a decision right now. Sorry. Oh, sorry. Wait. Sorry. We're going to swap to internet. We'll come back to you. Yes.
Question from Mart. Can you tell us a little bit about the portfolio that IDEO CoLab is working on with blockchain technology right now, and also what the interest from companies and industries are in blockchain?
Okay, talking about the portfolio that CoLab is working on and the companies and industries that are interested in blockchain technology. Okay, so we're interested in a lot of things, working on a lot of different things with blockchain technology right now. One of the areas that we're excited about is crypto collectibles. So some of you may have seen like crypto kitties, these like blockchain-based cats. Seems like really silly use case, but we think that there's actually a lot of interesting thing around this kind of human nature towards wanting to collect things. And we think it's going to be an interesting way and very compelling way once we get more traditional kind of artists and game designers involved in terms of introducing people to some of the paradigms that we've talked with here, right? Games are a great way to kind of train people about new paradigms. We're very interested in decentralized exchanges, the idea that you don't need to have kind of this trusted central entity and intermediary. You could actually have what are called atomic swaps, where you're trading assets directly and you don't have to worry about any kind of counterparty risk. We're looking at all sorts of kind of scalability solutions for blockchains, and really thinking about like, what does it mean to have a kind of a wallet, a decentralized application browser? What is the kind of primary user interface going to be in this blockchain-based world? In terms of companies and industries that we're seeing that are interested in blockchains, I'm struggling to think of like an industry that I haven't seen a company like look at blockchains and see if they're useful. Financial services was kind of the first place. I think kind of 2015, they were really looking at blockchains a lot. They still are, and actually moving into deployment now. We're seeing stuff across supply chains, across healthcare, IoT, automotive. Just every industry is looking at it. I would say that a lot of the use cases around blockchains are actually not good blockchain use cases for some of the reasons that we talked about here, in terms of issues with immutability with transparency and privacy. Sometimes a lot of cases that we see, people get excited about automation through things like smart contracts. But if there's not a trust problem between entities, you can just use a computer, right? Just automate it, digitize your process and automate it. But what I will say is that even for cases where, from a technical perspective, you may not need a blockchain, it can sometimes be really good from a kind of business perspective and getting people at the table and saying, hey, we need to collaborate as an industry and figure out some shared standards. And we can actually say credibly, we're not going to be holding to one party. We're all going to jointly participate in maintaining some new infrastructure. So I think even in cases where you don't need a blockchain, there are good business reasons sometimes to take a blockchain-based approach. Come back to you for your question here.
Can you give me some examples to see how blockchain is already like real application? Because I know there are some for supply chain areas, like something that already like application to industry.
Yeah, there are some supply chain examples. So you're asking for applications where blockchains are being used. There are some supply chain examples that I think are more, so big companies like IBM and Maersk are investing a lot in some of these things. So they're currently POCs and probably going to be real very soon. But I actually think the bigger use case that we're seeing right now is digital assets, right? Bitcoin itself, I think, is an incredible innovation. And now we're seeing people issue tokens through these token sales or ICOs and different things, which, a lot of them are really not necessary, but some of them are genuinely innovative. And so I think this new way of approaching kind of organization of kind of human and financial capital is really interesting. And we're seeing billions and millions of dollars. I think it was 4 or 5 billion last year. We're already over that mark in 2018, just where we are today. So I think it's really on kind of financialization and a whole new asset class. That's where it's getting used right now. So I think people get very caught up often in looking for what are new ways that we can use blockchains, saying, I'm not interested in Bitcoin, but like blockchain, let's use it. We really think at CoLab that these digital assets, these public permissionless networks for transferring value are a massive innovation. And we've only begun to scratch the surface of how they're going to change the world. Yeah.
I really like the blockchain example, and I'm mostly familiar with Bitcoin, so I'm curious, how is data like that written on a blockchain when it's not really a transaction, it's not tokens moving?
Yeah, okay, so the question was, for the blockchain example, how are we writing data on the blockchain if it's not transaction, like there's not a token moving? And so the answer is, there are kind of fields where you can basically jam extra data. And generally what you're going to want to do is not put like a whole bunch of data, because it's actually very expensive to put data on the blockchain. So you're going to want to kind of keep that as small as possible, probably have kind of a pointer to somewhere else where the data is living. So at least you can prove something happened and like, oh, and go here for more details, but you're putting a hash so that you know that when you retrieve the data, it is the data, like that data hasn't been changed, even though the data itself was not on the blockchain. So that's a little technical explanation, but yeah. Yeah.
So bear with me, I might not articulate this well, but you mentioned the concept of, so a lot of blockchain solutions are generating a 256-bit identifying string. That's you.
Mm-hmm.
But you mentioned the concept of having that carry across platforms, and that's more of your identity in the blockchain world rather than just in one specific scenario. Based on your experience and where you think blockchain is going, what do you think the ideal solution for that string is?
What do you the ideal solution for private key?
I guess more about identity, that string representing someone.
So what do you think about like that string, that key, that address representing someone? Thanks. So yeah, Bitcoin. Someone picking up even more. That's great. Yeah. So I don't think that. Yes. Yeah. So the question was around how do we think about using properly keys in an identity context. I think generally you're not using most of your identity isn't kept on the blockchain. Most of the activity isn't publicly there. You're just using that key as an authentication mechanism and keeping a lot of your kind of personal data off-chain in a storage either locally on your device or with a cloud service provider and providing that in different contexts. Think of it as basically a more secure way of doing like a username and password to authenticate yourself. Also, you don't want one key, one person. One of the amazing things about this technology, you can generate like as many keys as you need. And so if you want to use a different key in each context to prevent your identity from being correlated across different services, you can do that too. So it gives people kind of optionality and trying to figure out where you want to kind of use the same identity and where you want kind of unique and different ones. That's something that we need to figure out, like collectively as a society, right? Go to Shia for what's online.
A few different ones, but start with previous one from AJ. Is it possible that blockchain could replace current database systems like MySQL or Oracle?
Is it possible that blockchains could replace current database systems like MySQL or Oracle? For general purpose, no. Blockchains are horribly inefficient databases. They're really good when you're dealing with multiple parties who are having transactions and who don't trust each other and don't trust any one party to be kind of an intermediary for them. So in that scenario, blockchains are great. Outside of that, if you only use a blockchain if you like have a really, really good reason to do it, because yeah, they're really inefficient. There was one in the back that I was, yeah.
When you design our apps or product on top of the blockchain platform, what are some design challenges and how IDEO CoLab deal with those challenges?
So I think we actually, the presentation was mostly about like some of those challenges, right? In terms of thinking about dApps and in terms of like key management and permanence or reversibility. I think the asynchronicity was a great point to bring up as well. So yeah, these are all challenges that like we're thinking about day in, day out in terms of how to interact with dApps. Yeah.
So you shared about key management, and if I were to send Bitcoin to someone else for that, I still have to put his public address. So that system is still quite complicated for mass adoption. How do you see this in an easier, simpler way for mobile?
So the question was, if you're sending like Bitcoin or some other digital asset, you still need to put in a public address, which is this like weird long string, and it's not very user friendly. And how does that work in like on a mobile context, for example? That's a great question. I think there's a lot of people taking different approaches in terms of thinking about that. There are a number of companies that are working on essentially self-sovereign identifiers, DIDs, distributed identifiers. And so these are ways that you can essentially tie a unique human readable ID that is provably kind of unique and attach it kind of behind the scenes to one of those addresses, one of those public keys. So that's the thing, just having it human readable. It also opens up some risk, right? If you have a username you're using consistently and then somebody else grabs on one of these systems, there's no central authority to be like, hey, they're like squatting on my ID. So you have to be very careful about that. Yeah.
Guys working with any healthcare institution adopting blockchain, and also do you see how does blockchain working with the GDPR regulation?
Yes, the question was, are we working with any healthcare organizations around blockchain, and how do blockchains interact with GDPR? So yes, so one of our members is Blue Cross Blue Shield, Massachusetts, and we actually, even before they were a member, we were seeing a lot of health and healthcare based concepts kind of coming up in the prototype. It's a very human context. People care a lot about it. And so it just keeps coming up as a use case. So there are absolutely, I think, a huge boom in terms of people in the healthcare industry looking at blockchains right now. Some of the use cases are compelling, some are less so. But I think it's healthcare in terms of exploring blockchains is kind of like where financial services was a couple of years ago. So there's still a lot of kind of like internal prototyping and POC development. I don't think we're super close to seeing anything go live to production. And then the second part of your question was, GDPR. So general data protection regulations in Europe. So yeah, there's a lot of really tricky questions in terms of how GDPR interacts with blockchains, which are immutable and public. I don't have a good answer to that. I think Coin Center, which is kind of a policy and advocacy group around blockchains and digital assets, they actually put out some memo kind of proposing a framework and like saying we need to handle blockchains a little bit differently because they just don't work the way that we expect other things to work. Yeah, there's, I think, perfect answer to that, and we're gonna have to all figure out together. And that's true for a lot of blockchain-based things, right? All these idea of these like tokens, are they money? Are they securities? Are they commodities? Like they don't fit cleanly into existing frameworks. So to figure out when the frameworks need to change or when we need, I don't know. Yeah.
Cyril, blockchain looks like it will be this decade's tech. It's remains, but besides adoption, what are the major roadblocks ahead? Because I know you partially answered this in your question. The follow-up there is, why are transactions so slow? What are some of the things being done to speed that up?
Okay, I'm just going to answer the latter question. So why are transactions so slow on blockchains and what are being done to speed that up? So there is generally a direct correlation between the speed of transactions and how much finality it has, like how confident you can be that like it's not going to kind of be changed, that everyone else's consensus as to the state of the blockchain. So there are some things being done in terms of these, which are called layer 2 solutions, and these networks being built on top of blockchain, so that, for example, if you and I want to send a lot of Bitcoin transactions back and forth, we can open what's called a payment channel, where we just do one transaction on chain to create this kind of stream between us, and then one layer. But we can send an unlimited number of transactions back and forth just between us, and not have to worry about, like we still have the same, basically same security guarantees as doing on-chain Bitcoin transactions, but you don't have the delays, you don't have the cost of doing that. So that's one way we're kind of looking at speeding things up and yeah, adding more capacity. Question back there.
Also, on the speed thing, it depends on blockchain to blockchain because there's tons of ways of speeding each blockchain up. Lightning region.
Yeah, there's always trade-offs. Yes.
Yeah. No, and another point on GDPR, HIPAA overrides GDPR, so therefore HIPAA by default will always override on the tech, whatever you're doing by blockchain. But my question when I started was, I work in the was around the fact you talk a lot around the usability towards users who already understand what blockchain is. And one of our greatest challenges is how do you do UI interface for those who are not technologically prepared to be entering the blockchain space? And how do you introduce them to that? Because they enter, they think that, oh, they're going to get a web experience, and they just don't. So how do you prepare them for that?
Okay, so the question was, how do you prepare users who are not aware that they're interacting with the blockchain or they're not blockchain savvy? Yeah, I hope maybe the examples weren't the best for that, but like we think about that a lot. It's not just how do we make this better for people who are aware of blockchains. We realize that the percentage of people in the world who even heard of a blockchain is like low single digits, right? So yeah, we need to be designing in terms of helping people who have no context understands what's different. And so I think like the example with like copying the key was like, that's like one thing you can do to like a flag, be like stop, wait, and then like cause them to pause. There are things, finding systems where you can kind of build in reversibility. I think I referred to like Gmail undo send as like one of those kind of things that we can't do, but actually you can. One of the nice things about blockchains is you can find ways, if you're willing to, if it's in a context where you are willing to have a semi-trusted party or a trusted party to a certain extent, you can build a limited amount of reversibility in. You can do these things on top of an irreversible system.
So you're talking about having some off-chain usability where the user is a little bit more comfortable with what they're getting into, which then validates their entry.
Yes, in terms of doing stuff off-chain, or for example, you can use things like escrow contracts, right?
Yes.
And do things multi-sig, where you've got a company like BitGo or others who hold one key, right? And then they're going to run their own kind of fraud checks and things like this to make sure it actually is you and somebody else hasn't stolen your keys to a different location. So there are ways to kind of bring in help to protect people a little bit more. But there's not we don't have a this is how you do it. That's why we build prototypes all the time, so we can try to get closer. Yeah, the back.
If you have a flexible block size with respect.
Sorry,
If you have a flexible block size with respect to the timestamp. Flexible block size with respect to the timestamp.
What about the blocks? The block size?
Flexible block size.
Can you have a flexible block size in the public blockchain? With respect to timestamps?
Let's take an example. In 1 minute, you get 10 transactions, which is less than 1 MB. Rather than having the empty block of 1 MB.
Okay, I'm not sure I'm getting it quite, but you can have flexible. There's flexible block times. There's flexible block sizes. Yeah, you can. Different blockchains have different block sizes.
In one blockchain, you have
Yes, some blockchains have dynamic block sizes. Yes. It is absolutely possible. Whether it's a good idea is another question. Yeah.
So I see, or at least I hear about a lot of industry-specific tokens, and in some cases it seems to me like it would make more sense to have the industry-specific somewhat general token. I'm just kind of curious that where if you see a lot of merit for industry-specific.
Okay, so the question was, do I see merit for industry-specific tokens as opposed to industry-specific user interfaces? I generally do not see a lot of merit to industry-specific tokens. Right, the nice thing about the dollars in my wallet is I can spend it in any industry. So it creates additional friction to do that. There are some cases where, for a particular application, you want a particular token for that. Generally, it's not to use as a medium of exchange. Those feel very forced. In terms of standardizing user interfaces, yeah, and I would say even across industries, we've got some new paradigms. We need to figure out best practices for handling those paradigms across industries, but particularly within industries, right? Anytime you can get similar services to have more similar interfaces so users know what to expect, that's going to be helpful. Yeah.
Do you have an example of companies that build blockchain-based products without the end user really actually realizing or having to going through the pain of it and what they did well?
Great. Okay, so the question was examples of companies essentially blockchain-based products with the end users not realizing that there's blockchain-based product. Yes. So one example of that is a company called Tyrion. And so what they're doing is they're essentially kind of providing these kind of blockchain notary services. So you can basically have the data notarized. The user's not realizing the data is getting notarized, but it is creating essentially proof tied to a public immutable blockchain. So that can happen, and it's good for audits, but the end users of the service don't even realize that the data is being captured in this kind of verifiable way.
But the company then will have to basically tell them it's in this technology back and nobody could.
Well, yes, the question, the company still has to tell them no. Well, it depends who the user is, right? In some cases, it's for auditors, right? So the auditors can look at this, but the end users and customers don't need to. So that's one case. There are some companies that are doing kind of remittances where they're using digital assets to kind of transmit, between countries and then doing conversions, and the users aren't realizing it. Sometimes that makes sense, sometimes that doesn't. I think we are going to see a lot more services in the future where the user isn't aware of it on the end. I think the first case is we're starting to see that like in the securities context, where some securities are actually now legally being issued on blockchain, some permissioned, some public, but mostly permissioned ones. So there is a blockchain there. The shareholders may not realize their shares are being represented on a blockchain, but it provides much improved record keeping and make sure you don't have problems that some companies have with like there's more shares like outstanding than they've issued. Like that can't happen if you're using a blockchain to track it. Do we have, I don't know how we're doing on time, but okay.
A question around platform usage. Does IDEO CoLab have any opinions on what kind of blockchain platform like Ethereum or Hyperledger, if so, why that platform?
So the question was, does CoLab have opinions on blockchain platforms like Ethereum or Hyperledger or other platforms? We have the opinion that there are different blockchains, different platforms that are useful in different contexts. Hyperledger is really focused on these kind of private blockchain consortiums and kind of using these to not public permissionless blockchains. They are permissioned in some way, or then usually private, although they can be public and permissioned too. That is a use case. In our opinion, generally, we're more excited about these public permissionless blockchains. I think that's where the real innovation is. If you look at kind of like network computers, private networks of computers are valuable, they are useful, but they are dwarfed by the value of the internet, of having an open kind of public permissionless network of computers. And I think that blockchains are similar. So allowing for permissionless innovation in terms of kind of value transfer and the types of interactions that are possible using public blockchains, there's going to be a lot more happening there because you don't need to be part of an industry consortium and ask for permission to do things. If you've got a good idea, you can just go do it, you can ship it, and people can start using it. And I think that's where we're going to see a lot more happening in terms of specific platforms. I mean, Ethereum is where most of the development activity is happening right now in terms of smart contracts and decentralized applications. Bitcoin for a lot of kind of just value transfer and store value. But there's a lot of other projects that are coming out there that are innovating and trying new things, and we're trying to keep up with as much of it as we can and see what's useful. So I think maybe one last question here, and then we're gonna break, and we can I'll stick around. We can talk to me and other members of the team too.
So I think you mentioned with Augur. So essentially, if you build your business logic or business model into a smart contract, risk that you can't really change the smart contract after that. Yeah. But at your early stage, if you want to change your business model in the future, how real estate would you change that? Would you fork it, I guess?
Okay, so the question is, for things like Augur, right? It's hard to change the contract, or impossible in some ways to change the contract after the fact. So how do you iterate on that to your business model? So actually, some good friends of ours with Zeppelin Solutions, they do Open Zeppelin, which is a great smart contract development platform. They're developing something called Zeppelin OS, which allows for upgradable smart contracts. And so I think you have to think very carefully about governance and some of the security risks and how you're managing the ability to make those upgrades. But it is providing a way that you can actually manage these contracts and have a path at least to upgrade them over time. In some cases, like there was some Augur earlier had a security audit, and they found that there was some problems with the contracts. They actually basically canceled out the old contract, issued a new one where it's fixed, and just rolled all the tokens over to the new contract. So you can do that in some cases at certain stages in the project. And when I say you, the thing to remember is you does not necessarily mean like the founder of a company or the employees at a company. Maybe you, the community of users of this decentralized application, may find some way to reach social consensus or potentially consensus by votes on a blockchain to make changes to the protocol, to what you're using. So there's always fallback to social consensus. That can be really hard to get though.
So right after the vote, right, there still needs to be some kind of admin accounts to make the changes, right? So some kind of government.
You say, okay, if you have a vote, then this means somebody who can make the changes.
Right.
Sort of, yes. So let's talk about that after, because that's complicated, and I think it's gonna take way too long to answer. Yeah. So I want to thank you all for coming and asking such great questions. We do have more food and drinks in the back. Hang out, talk with us. We'd love to hear what you think about these topics and what you're working on. And thanks to the whole team, especially Jacob for figuring all this videos so people who couldn't be here in person are able to watch it, and Shia for helping with all the presentation, and Scout for organizing this whole thing, and Ali C also for helping with this. And yeah, thank you all. So I'll talk to you soon. Thanks.